255 is the maximum number of chatter events that are recorded by every single input. Rather than simply say that an input has seen a chatter event, we do actually measure the number of chatter events that have occurred up to 255 on every input. That does give your engineering an indication of which contact is worse than another, and that can be quite useful. That is over and above the actual specification, but it's a very useful engineering feedback. So during the setup mode we can be plugging connectors, we can be moving relays around, and eventually you should obtain a situation where you can get all green indicators. So with green indicators, this is a good usual place to start the test. So at this point an actual vibration run can be performed. Now the operator normally starts a chatter detection test or a vibration test by clicking on this run button. There are two ways that this system can be used. Either the run button can be clicked and then an operator moves to a vibration controller and starts a frequency sweep immediately afterwards, or alternatively the Reflex 80 has hardware control that can be interfaced to a vibration table to initiate its controller into performing the vibration frequency sweep. For now we'll just click on the run button and we're starting a run, and you'll see this time the individual inputs fill up quite quickly. These are simulated chatter events, and fairly quickly they're both indicating greater than 254. So this shows that there have been chatter events on each of these three inputs, and the Reflex 80 continues capturing chatter events until it is manually stopped with this stop button. When it's stopped, the data is frozen and the operator can examine the screen, get an idea of whether there have been failures or whether another test needs to be run, or the data can be saved to a report file. To make a report file is very easy. We click on the reporting icon here, click on Make Report. You have the chance to name the report, and in common with most applied relay testing products, the report output is actually a document in Microsoft Word format. You can see here the three inputs that we've tested, their names, and the number of events that were captured, together with an overall header here. That report is a Word compatible document which can be emailed or saved in a very simple manner. Now, under this configure button there are a number of options which make the more detailed use of the Reflex 80 very useful. The learn mode in particular is extremely powerful, because you'll recall that in the beginning I manually configured these inputs to certain polarities because I knew what the connections were. When you've got several tens of connections, that can be quite tedious, and this wizard is designed to help you with that. What the wizard does is it scans all of its inputs in two modes. First of all in this mode with the relays operated, and then after you've released all of the relays it makes another scan. By performing these two scans, the Reflex 80 now knows which inputs are active and what their polarities are. Clearly, to do this you need to have a connection that you trust, but this can still be a very quick way of configuring the system in the first place or with a new fixture. So that's given you a basic introduction. To briefly touch on one of the advanced topics, the system has a hardware profile page. This hardware profile page comprises events that are fired when various Reflex AT conditions are met. So this tab is tied to the initialization of the software, this tab is tied to the setting up of the software, and this tab tied to running the Reflex AT capture. Now into these panels you can put individual commands. Commands are available for a number of different possibilities depending on hardware that's fitted to the Reflex AT system. And applied relay testing provide as standard a range of power supply controls and conditioning modules that translate between the vibration table controls and the relay contacts and the relay drive, such that you can build the system up from a simple slave capturing device, which is how I've demonstrated it here, into a really quite automated system.